Now we're going to start on solving equations. So I'm going to write a very silly, simple equation here to start with, right? So 11 equals 11. Obviously 11 is equal to 11. Okay, I hope that's clear. And we know it's an equation because right there is the equal sign. Okay, so again, I'm going to build the foundation strong so that way when we go up, things will make sense to you. So here is an interesting fact. If I take 11, this very, very simple equation, and I want to add the same number, say the number 3, to both sides, I end up by getting 14 on the left and 14 on the right, and that is still equal. Let's say I take 11, basic equation, and this time I would subtract 3 from the left and subtract 3 from the right. Then I get what? 8 equals 8. Still true, right? Still a correct equation. And this leads us to something called the addition property of equality. The addition property of equality. Now, the addition property of equality says that if the same real number is added to both sides of the equation, then that does not change the equation solution, right? The same real number can be added to both sides of the equation without changing the solution. So this simple idea is super useful when it comes to solving equations. So solve x minus 8 equals 3. Okay, solve x minus 8 equals 3. Well, the way we solve this is by, so first of all, before I go there, just let's make sure that we understand what solve means. Solve means find the missing variable value. So in other words, what is the number that should be in for x in order to make the left side equal to the right side? We could probably guess at that number as 11. 11 minus 8 is going to give you 3. So we know how that works. However, how would we do that if we didn't see it directly, right? And so we're going to use this addition idea, the addition property of equality. We are going to basically add a very special number to this. We're going to add a number that will cancel out this 8. So in other words, we're going to add a positive 8 to the left side. So here's my equation, and like we did above, in the problems above, we're just going to add a number. We're going to add a very special number, and this time we're going to add the number 8. And why 8? Because it will cancel out that negative 8. It's the additive inverse of 8, right? So this is the additive inverse. Additive inverse. One of those properties again. Okay, and so if I add it to the left, I must add it to the right, because that's the only way. Adding the same real number is the only way that we can get an equation without changing the equation solution, right? So in this case now, the 8's cancel out, and I get x on the left and 11 on the right, which is what we guessed at, x equals 11. So you can sort of see how using this addition property of equality, we can solve simple equations. Now there's another property And so to understand that second property, let's take a look at again our simple starting example. What was it? 11 equals 11, right? And so this time I'm going to multiply the left side by a number. So this time let's multiply the left side by 3. So 3 times 11 equals to, if I multiply the left side by 3, I gotta multiply the right side by 3, just to see, and I get 33 on the left equals to 33 on the right. Again, true. And so that leads me to um, the multiplicative property of equations. Okay, so in this one, it says that, just like the previous one, it says the same real number can be multiplied to both sides. The same real number can be multiplied to both sides without changing the solution of the equation. Okay, so that's what we see up here on the left. Multiply by 3 makes no difference. So for example, solve. Let's say we had 1/3 x equals 11. So I know that if I multiply the left side by a number and the right side by the same number, I get the same solution. But I have to be smart about the number I choose. Now I can choose any number I want, but if the goal is to solve this equation, I'm going to be really smart. And the number I'm going to choose is the multiplicative inverse, right? So the multiplicative inverse of 1/3 is 3. So this is the number I'm going to choose. So I'm going to multiply the left side by 3, and here's my that, and I'm going to multiply the right side also by 3, like so. And now, using the associative property again, I can multiply these two. 3 over 3, doing it slowly here, this is 33, and 3 over 3 reduces to 1, so x is equal to 33, and there is your answer. There is your answer. So we can, get a little bit more complex before we really get into the difficult stuff. Do one more simple example here. So for example, what if we had 5x plus 3 minus 2x equals to 7? Okay, so now what we're going to do is we're going to bring in our little knowledge from simplifying expressions first. We're going to simplify this left side first a little bit. And so that's going to take me, by combining my like terms, it's going to take me to 3x plus 3 equals 7. And now we're going to use our additive property of equations, and we are going to add in a -3 to the left side. And then we are also going to add in a -3 to the right side. So if I did that, over here on the left side, I get 3x, and over here on the right side, I get 4. And now I'm going to use the multiplicative property on the left side of equations. So I'm going to multiply this side by 1/3, the inverse of 3 over 1. And then if I did that to the left, I got to do the same thing to the right. There is that. And so over here, that's going to reduce, or first let's multiply it. And over here also, let's multiply this. And over 3 over 3, of course, we know is 1. So x is equal to 4/3. So right there, we have seen how to use both principles, both properties of addition and multiplication in one problem. Now we'll do more examples coming up, so make sure you watch the rest of the videos as well.